Hey everyone, welcome back to Math the Explorer, where learning math is fun and easy. Today, we're diving into something we use every single day, but probably never stop to think about. Did you know there are many different types of numbers? From the ones you count on your fingers, to numbers that go on forever, even numbers that aren't really numbers in the way you think. In this video, we'll break down the different types of numbers, how they're used, and why they matter in math and in real life. So, if you're ready to boost your math skills, don't forget to hit like, subscribe, and tap the notification bell so you won't miss our next lesson. All right, let's jump in and explore the world of numbers. What are numbers? Numbers are symbols or words we use to represent quantities, positions, and values so we can count, measure, compare, and calculate. Numbers can be represented in language with number words. More universally, individual numbers can be represented by symbols called numerals. For example, 5 is a numeral that represents the number 5. As only a relatively small number of symbols can be memorized, basic numerals are commonly arranged in a numeral system, which is an organized way to represent any number. The most common numeral system is the Hindu Arabic numeral system, which allows for the representation of any non-negative integer using a combination of 10 fundamental numeric symbols called digits. Different types of numbers. Number 1 in our list is whole numbers. Whole numbers are the set of all non-negative integers, including 0. They are the numbers we use for counting, starting from 0 and increasing by 1 each time. Whole numbers do not include fractions, decimals, or negative numbers. Examples: 0, 1, 2, 3, 4, 5, and so on. Next in our list is integers. Integers are whole numbers that can be positive, negative, or 0. Integer is a Latin word which means whole or intact. This means integers do not include fractions or decimals. Examples of integers are -4, -3, -2, -1, 0, 1, 2, 3, 4. Next is rational numbers. A rational number is any number that can be expressed as a fraction where both the numerator and the denominator are integers and the denominator is not 0. Essentially, any number that can be written as a ratio of two integers is considered rational. Examples: 1/2, -3/4, 5, which can be written as 5/1, 0, which can be written as 0/1, and even repeating decimals like 0.333, which is 1/3. Next to this is irrational numbers. Irrational numbers are real numbers that cannot be expressed as a fraction. They have non-terminating and non-repeating decimal representations. They cannot be written as a simple fraction of two integers. Their decimal representations go on forever without repeating or ending. Essentially, they are numbers that are not rational. Examples of irrational numbers: square roots of non-perfect squares, square root of 2, square root of 3, square root of 5, square root of 7, etc. Pi, approximately 3.14159. The ratio of a circle's circumference to its diameter. Golden ratio, 1.618033988. The ratio of two quantities where the ratio of the sum of the quantities to the larger quantity is equal to the ratio of the larger quantity to the smaller quantity, and closely linked to the Fibonacci sequence. Next is real numbers. Real numbers are all the numbers that can be found on the number line, including both rational and irrational numbers. They encompass all the numbers we typically use in everyday calculations and measurements. Examples: integers, -3, -2, -1, 0, 1, 2, 3. Fractions, 1/2, 3/4, -5/7, 2/5. Decimals, 0.5, 0.75, -1.2, 3.14159. Square roots. square root of 2, square root of 3, square root of 5, square root of 10, pi, approximately 3.14159. Other irrational numbers. The golden ratio, 1.6180333988. Next one is imaginary numbers. Imaginary numbers are numbers that, when squared, result in a negative number. They are defined as the product of a real number and the imaginary unit I, where I is defined as the square root of -1. For example, I equals square root of -1, or I raised to the power of 2 equals -1. Essentially, they extend the concept of numbers beyond the real number line by introducing the square root of negative numbers. Examples: square root of -4. This can be simplified as square root of 4 times -1 equals square root of 4 times square root of -1 equals 2i. 5i. This is an imaginary number because when you square it, 5i times 5i, you get 25i raised to the power of 2, which simplifies to -25. -7i. Similarly, squaring this gives -7i times -7i equals 49i raised to the power of 2 equals -49. Next is complex numbers. Complex numbers are numbers that can be expressed in the form a plus b, I, where a and b are real numbers, and I is the imaginary unit, defined as the square root of -1. For example, I raised to the power of 2 equals -1. The I part is called the real part, and the b, I part is called the imaginary part. Examples: 3 plus 2i, real part is 3, imaginary part is 2i. -1 negative, I, real part is -1, imaginary part is -I. 5 can be written as 5 plus 0i. Real part is 5, imaginary part is 0. For I can be written as 0 plus 4i. Real part is 0, imaginary part is 4i. Lastly, other important classifications. Even numbers, divisible by 2, for example, -6, -4, -2, 2, 4, 6. Odd numbers, not divisible by 2, for example, -5, -3, -1, 1, 3, 5. Prime numbers have exactly two distinct positive divisors, 1 and the number itself, for example, 2, 3, 5, 7. Composite numbers have more than two factors, for example, 4, 6, 8, 9. Fractions represent parts of a whole, expressed as a ratio of two numbers, for example, 1/2, 3/4, 5/6. Thanks for watching. If you enjoyed this video, don't forget to give it a thumbs up, share it with your friends, and subscribe to the channel for more awesome content. And hit that notification bell so you never miss an update. See you in the next one.